Hey guys, this is section 4.4. This is a bit of a shorter section, so it probably won't take us too long to get through. So let's just get started. Okay, so check out the pictures on the page here. This is kind of what I need to make my point. So when we talk about lines, we usually we present them to you in this way, right? So it's like this nice solid straight line, and it's like, oh look, I can just connect the dots and we're all good to go. But the issue is that most things don't actually work this way. The real world tends to be more scattered, and that looks more like this situation down here. Now, here's the thing. If you look at this scatter plot, which is what this is called, so this is you take a bunch of data and you plot it just like you would with a regular line, but you put it down, and when it looks like this, it looks scattered, so we call it a scatter plot. But the one thing you can say about this is that it looks like this data is going in a direction, right? And what you could do pretty easily is you could imagine drawing a line kind of through the center of this. So if I try that, it might be something that looks something like this, right? And this is what today's lesson is about, this idea of actually coming up with this line here. So let's now go into it. So a scatter plot, this is a graph that plots every data point in a set of data on two sets of axes. And it can help illustrate whether or not two variables have a particular relationship. So here is one graph that normally when I have class, I ask my students to look at the axes and try to come up with, what do you think that this could be modeling? So I want you to notice, like, this is still kind of a scatter plot, and notice, like, so the lower the data is, the lower the x value here, the lower the y value. But look at the particular values. What do you think this could actually be talking about? Maybe you want to pause the video and just come up with a few guesses. So I actually modeled this data off of the age of children. And the other side could be their weight. So let's see if I can write that on the side here. Weight. That's actually what I had. And this makes sense now when you look at it, right? So this would fit as a scatter plot, right? You can kind of imagine that line going through it. And so this would be the type of real world data that I'm talking about. So the age of children, they should have around a particular weight, but there's always outliers too, right? So like this kid weighs a lot more. Maybe this kid is also a lot taller. This kid weighs a lot less, but maybe this kid's a lot shorter. So there's like a general range that people tend to fall into. People will not always be there though, so there will be what's known as outliers, like these points here. But that's kind of the gist of it. Okay. So now I want to take a moment just to kind of talk about a few terms and try using them with another example. So scatterplot language. We have the term correlation. So correlation is a measurement that determines the strength of a relationship between two sets of data. Man, I just have all kinds of typos in this, don't I? Good help is hard to find, especially when it's yourself. Okay, so typically so a correlation, the big thing about it, this is a decimal anywhere from -1 to 1. And this number is also referred to as a correlation coefficient. Now, when you're talking about correlation, you also have what's known as an independent variable and a dependent variable. So, independent variables, when determining if two sets are correlated, these are variables that do not depend on the other set. While dependent variables, when determining if two sets are correlated, these are variables that are increased or decreased based on an input from the independent variables. So they rely on the other set. So, if you think back to our last example, so this would be what we consider this is correlated, right? It looks like the age definitely gives you an idea of what the weight should be. And age is the independent value. If I tell you the age of a kid, you can probably come up with a range of the weight. You have an idea of what the weight should be. But if you think about it, if I just told you the weight of a kid, you might not know quite as well. You might have a range of the age, but like if I tell you the age, I think a lot of times you have a much stronger sense of kind of what the weight would be. So age kind of implies what weight is. Okay, so with that in mind, I have one other example. So you can see I have the axes here kind of leading you towards a thought. You might want to pause this and think about it for a second. What situation is this depicting? And in that situation, what are your independent and dependent variables? Okay, so I have heard all kinds of really great things about this one. I will tell you what it was actually depicting. Although if you want to write in the comments what you thought that this was, that would be great. Because I've gotten funny responses. I've gotten pretty good guesses. Nobody ever gets what this actually is. So this is actually a scatter plot modeling the number of red light tickets given at a particular time. So this is, most people get what the x-axis is. This is time. And this is number of red light tickets. But there are lots of other things you could have come up with. So this is actually a little bit of a creative exercise. This doesn't have to be like, oh, I got it wrong or whatever. There's lots of different ways you could think of this. So I'm totally fine if you're creative. Now, I want you to notice though, one weird thing about this is a good kind of example. So this isn't totally linear, right? It actually kind of has more of a spike to it. And so this is something that can totally happen with data. It's not like when you enter in data, it has to act a certain way. The real world can kind of have any outcome that it really wants. So this is an example of something that's not linear, but it's still a scatter plot, and you can still see a definite relationship, right? Now, if I wanted to turn it into something more linear, what I would want to do is maybe separate it. So for instance, maybe I'd separate it here. So this graph here, if I just had this graph, this would look more linear, right? It would look like something going up like this. Or I could separate it into this graph here. This would also look more linear, right? So it just kind of depends on what you're trying to do. So we're talking about linear scatter plots, but I wanted to just show you a different one. Okay, so now let's talk about some other terms. So now we have the idea of positive correlation, which means that two sets are positively correlated if an increase in the independent variable results in an increase in the dependent variable. They are negatively correlated if the increase in the independent variable results in a decrease. I'll tell you more about what those mean in a second. Strong correlation would be something where it looks very, very clear. And a strong correlation tends to be either closer to -1 or 1. So remember, I told you correlation falls between -1 and 1. So a strong correlation will be closer to one of those numbers, and then a weak correlation is closer to 0. So let's go back to the idea of positive correlation just for a second. So here's my idea here. Think about what a positively sloped line looks like. A positively sloped line looks like this. And so this is actually the same idea then as a positive correlation. Things that are positively correlated will look more like this. And the more clearly you can see the shape of a line from the data, that makes it a strong positive correlation. A weak positive correlation might be something more like this, or it might be really hard to figure out what the line looks like. But, you could still maybe tell it's kind of positive. Now, a negative correlation, then, if you're just thinking about this, it's going to look more like a negatively sloped line. So the more clear that line looks, and the more clearly it looks negatively sloped, then that's a stronger correlation, otherwise it's weaker, so you get the idea. Okay, so what I want to do to start is just kind of get you used to looking at graphs like this. So I have 6 graphs here. We'll start with the top 4 since I've already got those on the screen anyways. So I know we're not going in order here, but that's okay. Okay, so looking at this graph here, so for instance, this graph, just by looking at it, you can totally visualize and picture that line, right? You can picture this line. I would say that, so this is a negatively sloped line, so it is a negative correlation, and I would say that it's pretty clear for the most part that you have this line going this way. I know that there's this piece of data out here, but that's really an outlier, so we would call this strong. Now don't get super hung up on the terms here. Sometimes something you might not be able to tell whether it's positive or negative because it's so weakly correlated, so that's a total possibility. But I want you to look at these 4 graphs and just try to think of, can you come up with whether they're positive or negative or strong or weak correlations, and then hit play when you're ready. Okay, so this is pretty weak, right? And it's so weak, I really can't even tell which way the line would go. So if you said positive or negative, like yes, there's like no good way to say this. Now, what about this one? To me, even though I have this like weird data kind of over here, I feel like on the whole, I could kind of see this line kind of going through. So it's strong, we'll maybe call it strong-ish and negatively correlated. Or yes, it's got a negative line. So again, it's not like, it's not going to be perfect in this case. Now, what about this one? To me, this looks positive. The data is definitely going in this direction. So I could kind of make this line. So it's positive, but it's pretty weak, right? You have like all this data. It's not that tightly wound around the line. Okay, so let's just look at the last two together then. So what about this one? This one has a really clear cut line going in this way. This is an example of a strong positive correlation versus this one. Again, this one's kind of a mess. I really don't know if it's positive or negative, so this would be pretty weak. So the approach that we're taking for this, it's mostly just visual, and we're trying to give you a feel for this. And so that's good enough for now, just to kind of dip our toe into this topic. Okay, so I have one more thing I want to go through before I end this video. So I want to get you also used to the idea then of modeling out certain situations and independent versus dependent variables. So I have these 4 situations, and I want you to read them over, and I want you to try to match them up to these graphs, these scatter plots. So try to figure out which situation goes with which graph, and then use the axes to help you figure out the independent and dependent variable. So the independent variable is generally what runs along the x-axis, while the dependent variable runs along the y-axis. So you could use that as a hint to figure out what those are. So pause here, hit play when you're ready. Okay, so if I look at this, so the first one is the amount of time spent studying and the grade achieved on an exam. So if you notice here, this scale is going from 0 to 100. Nothing is over 100, so that would be this first graph here. So this is situation A. And the independent variable would be the hours, right? Hopefully the amount of hours that you spend studying will get you your grade. So there's kind of the idea behind this. So we've used A. Okay, so up next, the cost of butter and the percent chance of snow. So that's pretty ridiculous, and if you just think about your general intuition, those two things should not be related, right? So which graph makes the most sense for that? That would be this one here. And so now if I have to figure out which one is which, well, cost of butter, maybe this is kind of expensive butter, but somewhere between $4 and $5.50 it looks like. So the cost of butter would go here. And I only know that this must be the cost because this has to be the percent chance of snow, which has to be somewhere between 0 and 100. So that's like where I'm using that cue. Okay, so that one's done. The cost of gasoline and the average number of miles that a person drives per week. Okay, so now if you look at this, the one that makes the most sense for this is something like this situation here, see? Now sometimes people contest this when I bring this up, but think about this. If gas were $12 a gallon, so we'll go with a totally crazy example here. Think about if gas were $12 per gallon. How much would you actually drive? You'd probably drive as little as possible, and you'd probably also want to start carpooling with people, and you wouldn't be taking road trips and you wouldn't do anything like that. But if gas were like 50 cents a gallon, people would probably like not fly places, right? They'd probably be like, oh, we'll just drive because it's so cheap. So that idea, then the higher gas is, the less you want to drive. That idea is kind of represented here. And notice how this is pretty, like a pretty tight correlation, but it's not perfect. So this would be that situation. So the independent variable will be the cost of gas, and then the dependent variable is how much you drive, or miles driven, I guess. Which leaves, by process of elimination, this one to be D. So this is the height of a ball thrown off of a cliff. So now this one's actually a little bit tricky when you think about the independent and dependent variable. So if I'm sitting on a cliff, this is the first moment, and then after a little bit of time, as I've thrown this, it starts to come down to the ground. So this is actually time down here, and this dependent variable would be, oops, not height, height, not seconds. Okay, so this would be the time, and then this would be how high above the ground. So maybe I'll note that, height above ground, that this ball is. So after about 2.5 seconds, it hits the ground, so it's no longer in the air. Okay, so that actually covers it for this first part. So in the next part, I'm actually going to show you how to come up with the equation of a line for a scatter plot, which if you're doing one of my projects, this is actually the work that you need to do the project. So we'll talk about that in the next video.